All right, I think it's 3 o'clock here in Stockholm. So welcome to this webinar. My name is Jakob Ideskog. I work at Curity as a security expert, identity specialist, and a product manager. So most of my days I work on our OAuth server, OpenID Connect server, but I also help a lot of customers implementing and designing their API infrastructures and how to architect the whole system. So what we're going to do today is we're going to take a brief overview of what OAuth is. We're going to look at the code flow, which is the most common OAuth flow, and discuss some about how tokens work, what types of tokens they are, how they can be used. And I'm also going to show you a tool that we developed here called OAuth Tools that can be quite handy when you want to learn and explore OAuth on your own. So let me jump to screen sharing here, and I'm going to disable the camera. All right. So OAuth and OpenID Connect introduction. We're going to try to cover these topics. First of all, we need to discuss a bit about why should you do OAuth, what's it for? And in order to sort of dig in a bit into this, we need to understand who are the actors, what participants do we have in an OAuth flow, and why are they there in that form. And we're also going to touch OpenID Connect a bit, because it's hard to talk about OAuth without adding OpenID Connect on top of it. And like I said, I'll talk about the code flow, some tokens, and perhaps some scopes and consents also in the end. So why OAuth? Well, I can think of many, many reasons why we should use OAuth, but one of the driving factors almost always is that we have a bunch of APIs. Perhaps we're splitting apart our infrastructure, but we have a bunch of APIs, and we want to expose them to some application. That application may be external on the internet. It may be internal, but it doesn't necessarily have to be a third-party application. That's a common misconception, that once you start exposing APIs, you think they should be public, and that's when you need OAuth or OpenID Connect in order to protect these. But the most common case is actually that you're building your APIs for yourself and for your own applications, for your own mobile applications and websites and so on. So, but this is one of the driving factors, obviously. Another factor is that the APIs are being split apart. We used to have them as bigger monolith. We didn't perhaps even call them APIs because they were part of our backends, but we're splitting them apart, which means we also need to deal with how the identity model, how do we distribute identity between these, because we may not use shared sessions anymore, which obviously is an anti-pattern in a microservice architecture. We also want our applications to be more agnostic to the API's security requirements. What does that even mean? Well, it means we don't want to build in information about the user into the API itself, like a URL parameter, for instance. Say that you would have resource foo/user1/something. It's not a really good pattern when you're building an API. It could be useful if you're building a user API to actually get the user data, but for all other types of APIs, you don't want to have the user ID or any reference to the user in the API format itself, because it doesn't scale nicely when you're building other types of applications. So you want to pull out the API, the identity from the equation for the API. And that's what I mean. The applications then need to be agnostic. So when we're using the API, we somehow need to still send identity information. And this is a bit unrelated to the API, but we also want the application in a lot of times to be agnostic to how the user authenticates. And this has been a bigger requirement lately, or the last couple of years, as we're moving to more variants of signing. we might not only be able to have one type of login that we can provide, but we may have to provide many, like Google, Facebook, our own. Maybe a lot of companies acquire other companies, but they can't really merge all the user identities. So they need to have options of, if you're coming from that direction, you need to sign in like that. And if you're coming from this organization, you're going to sign in like this. But we want it seamlessly, and we want this to work with all of our APIs. So once again, it's all about pulling the identity out of the equation of building the application and building the APIs. And if you are building APIs that are going to be used by third parties, we definitely don't want that third party to see your users' credentials. And this is the original use case why OAuth was designed, and its predecessors as well. So OAuth came out of the problem that started to occur for Yahoo and a few other companies back in the days when they started to provide services, APIs essentially, to third parties, and the users were in Yahoo. They didn't want that third party to send basic credentials or anything like that for the user, because that meant they would share who the user was, and they obviously also didn't trust all these third parties with the user's credentials. So in many cases, you don't even want the third party to know the user ID. You don't want them to collect that type of information. They perhaps should just get some anonymous type of ID from your organization. So OAuth was developed to decouple this, so that the applications that were built, the mobile applications or the websites, any integrator to your API, wouldn't see the user itself. They would get some sort of token that they could use instead to use the APIs. So in order to understand what I just said, it's good to look at these OAuth actors. In OAuth, in the base specifications, there are 4 actors that you need to be aware of. We have the resource owner, which is a fancy name for the user. And the resource owner doesn't really interact in the technical way. It's the user providing credentials or providing login or initiating the flow. We have the client, which is an application that wants something. Could be a mobile application, could be a server application or a desktop application or a web, anything. That's the client. Then we have the resource server, another fancy name for an API most often. And we have the authorization server, which is the OAuth server. I'm probably going to say OAuth server more than authorization server in this overview. So why do we call them this? Well, the resource owner is called the resource owner because we assume that the user has some data at the resource server. So the user's data is located there. That's obviously not true per se. The user doesn't necessarily own the data that's there. But we can think of it, when I log into my Gmail account, I want to see my emails, not anybody else's emails. Or when I use some other service, my bank, I don't want to see other people's accounts, or I shouldn't at least. So that's why we think of it like this, that it's the user's data. So the resource server has the user's data. The client, on the other hand, wants to do something. It needs access to the user's data. And it can only get that if the user allows it. The client could perhaps be an email client, an email application that I want to download and use against my Gmail account, or some third-party bank application that can give me a better bank statement or balance update than my regular bank application could do. So maybe I want to use that to read my account information. So the client needs access to the user's data. And then we have the authorization server. The authorization server is the delegating party. Here, the user somehow says, okay, it's okay for this client to access data on my behalf. So the authorization server really is badly named. It's really a delegation server. It delegates access on the user's behalf to the client, and the client can then later use that to access the resource server. So that's the relationship between the actors. So with that, we can understand that OAuth, despite the name, is a delegation protocol. It's there to provide API access for a client to an API. That's it. What it doesn't do, it doesn't give any details to the client about who the user was that just logged in. Anything like that. It's all hidden. All the client will ever see is a token that most often is transparent, so it cannot view it inside. And it can only pass that to the API to get data. So if we want to provide some data about the user to the application, to the client, then that's when OpenID Connect comes in. OpenID Connect is an identity layer on top of OAuth. So it's a protocol that builds on top of OAuth, which means that if you use OpenID Connect, you have OAuth, not the other way around, though. So OpenID Connect defines things like how can authentication be triggered, how can we request certain data around the authentication, how can we know who and what and where, and so on. You can also control the authentication. You can say, I require this type of authentication, or it to be done this recently, things like that. And these things together means that OpenID Connect is essentially a federation protocol. For you who have worked with protocols like SAML before, SAML is there to communicate identity data between websites, essentially, cross domains. I log into one website, click a button, and then I'm logging into another website on a completely different domain. That's where SAML came from. OpenID Connect can do the same thing, so it adds sort of also a federation capability on top of OAuth. So OAuth, if you think of it, it's actually a protocol for protocols. There's more protocols built on top of OAuth because it's a really good base to structure other identity systems on top. There's UMA, for instance, for delegated authorization as well, and there's others. All right, so with that background, let's look at the code flow. This is the most common flow in OAuth. You'll see it everywhere. It's not, on the other hand, always used, and many times when other flows are used, that's because it was easier or they didn't have the capabilities enough to run the code flow, but it's very often the flow you should run, and here's why. So in the code flow, we involve all actors. We have the resource owner, and in this example, sorry, seems like I have a delay on my slides here. Let's just wait till it pops up. All right, so now you should see my resource owner and my client and my authorization server here. So the resource owner is accessing a website. It might as well be a mobile application or some other app, but it has a web capability. What happens then is that I want to log in order for this website to gain access to the resource server. So the first thing the client needs to do is it needs to send a GET request to the authorization server. And it does this in the browser. So it essentially just pastes a new URL in the browser, and you get redirected. The user gets redirected to the authorization server. It sends a few parameters in this request. It sends the client ID that explains what client we're dealing with. Of course, you could spoof this and send some other client ID, but we'll get to later why that doesn't work. And you send something called a scope. Scope is defining what type of access am I looking for. So you can think of it as scope of access. And in this case, we're sending the read scope. So we want to read something. That's a silly scope, perhaps. It could be more intrinsic or more detailed than that. And we say a response type. This is how to tell the OAuth server we're doing the code flow. So response type equals code. And then we're sending a state. And the state is there so that when we get called back later, we can know, okay, yeah, it was this session that started the flow. And now when I get back, I can match it and pick up the same session again, perhaps. So that's the start of it. And the code flow, yeah, you see the parameters on my next slide here, a bit more sketched out. I should mention that there's an optional parameter in OAuth called the redirect URI. It's not optional in OpenID Connect, which is why I'm adding it here. It simply says, when done, redirect back to this URL. It's optional because you have to configure all redirect URLs in the OAuth server. So you cannot send something that's not known on beforehand by the OAuth server. But if you have many configured, you need to send the redirect URI, because otherwise the OAuth server won't know where to go back to. So now the authorization server got this first authorized request, we call it. OAuth is very, very careful and very, very specific in saying, we don't know how to authenticate. It's completely out of spec to figure out who the user is. So an OAuth server really shouldn't do that. And that's why we introduce a component called an authentication service. So commonly, and in Curity and other products as well, you go to some other part of a system to authenticate the user. So we redirect up to the authentication service. There, the user logs in. This can be by hook or by crook, essentially, using multi-factor, single-factor, social IDs, whatever. It doesn't really matter. When the user has authenticated, it gets redirected back to the authorization server. And we get to number 4 here, the last arrow. And this is important. The OAuth server then decides, yeah, this looks good. I'm going to issue something called a nonce, a not more than once code, and redirect back to the client. So once again, we redirect. So this is the callback URL that we saw in the earlier requests, the redirect URI. So that's predefined. So the client is listening to this, and it will, once it gets a get on that, it will see, oh, there's something called a code parameter on there, and the code is a one-time code that I can use to get some tokens. And I also see the state being sent back to me, the same state that I sent in the beginning. So now we've done the first part of the code flow. So let's continue. Snapshot of the parameters we got back. So the second part of the code flow is interesting. We're on arrow number 5 now. The backend of the client, if it's a web client, makes a post to the token endpoint of the OAuth server. So we don't use the same endpoint, the authorized endpoint that we used to interact where the user interacted. Instead, we use the token endpoint. Here we pass something called a grant type in, where we explain, now we're going to send you an authorization code that we just got because the user authenticated and we assume we're allowed to do this. We're also sending the client ID again, telling we're this application, client 1. And this time we also need to send the client secret, so we need to authenticate the client. In the first flow, the user authenticated, and we only said we're client 1, trust us. Now in the second flow, the client authenticates. And lastly, we send the code, which is a one-time code. Again, this code now being sent will now be verified by the authorization server. And if that's deemed to still be valid and issued for this client, client 1, we might get some tokens. So here's the request we just sent. I'm going to show you this in the tool later. So the response will be a JSON document with some tokens. So we've now successfully run the entire code flow. It looks like a lot of arrows, but essentially it's just 2 parts. First part happens in the browser, where we redirect to the OAuth server. It takes care of everything and so calls the authentication service. The user interacts and just redirects back when done. And we extract the code, send it in a back channel call to the token endpoint, together with our client credentials, so we can authenticate the client and prove that we are who we say we are as application. And then the OAuth server will respond and say, sure, that looks fine. Here's some tokens for you. And we got 2 tokens back. We got an access token and a refresh token. Or we could get an error response, obviously, if something happened. A common error you would get is this one, invalid grant. Probably won't say some descriptive text, but it probably will say authorization code not valid, because the authorization code that we sent in is pretty short-lived. It only lives for usually 30 seconds. Might be shorter, slightly longer. Not a lot, though. So when doing this by hand or in Postman or something, it's pretty common that you don't have time to copy it from the browser and paste it in time and click send, so that you actually will get something, and instead you'll get this invalid grant back. So let's take a look at this before we do anything else. So we developed a pretty handy tool. Just going to copy a URL here, called OAuth.tools. Oops. So the URL is simply OAuth.tools. And what you can do here is you can work with an OAuth server, any OAuth server, and explore these flows. So I'm going to run the code flow that we just did. In order to do that, I just need to tell it, where's the OAuth server? And many servers support something called WebFinger, where you can discover the OAuth server. So it found the issuer, and then it finds all the URLs. And it does this by calling something called a metadata endpoint, which OpenID Connect defines. This is very, very useful, because that means your application don't have to be configured with everything about your OAuth server. They can discover it. All the endpoints are there, all the scopes that are available, all the authentication methods, signing algorithm, all kinds of goodies are in there. So we can see now, okay, we can support these response types, these authentication methods, these keys are published, scopes, etc. There's a lot in here. The only thing that it doesn't expose is the clients, obviously, because those are secret. Those we are only supposed to know. So I'll add a client here, one that I've configured. Oops. And we say this client can do these things. It can be framed. I'm going to name this environment my security installation, save it. And now let's start a flow. So I can click Start Flow here, do a code flow, which is the one we just saw. And we can see, yeah, OAuth Tools has this callback URL, which means I need to configure that in my client, just like we saw on the slides earlier. So I'm going to use the Tools client. I have this security environment that I just created. And I'm going to ask for a read scope. And then we're going to start the flow. So here I can see this new URL that's going to be called with all the parameters we just saw. So I'll click Run. And then it redirected me to a login. I have a pretty handy one, which only needs a username, which is good for demos. And now we got redirected back, and we got this authorization code. So I can redeem that, which will be this post command, post HTTP request. And I got 2 tokens. These tokens here are opaque, so I can't really see what's in them. But there's something called introspect in OAuth. That's good to Google. That's a way to call the server and say, hey, I got this token, what's inside? If I click this button, it calls the introspect endpoint. And I can see this token now contains a subject, me. It contains who issued it, what client was it issued for, etc. Lots of useful stuff. This is essentially what an API would see. So that means that once the token reaches an API, it will somehow decode it. There are various formats of tokens, and it will see this content inside. That means your token is the contract between your OAuth server and your APIs. So if you want account numbers or subscription IDs or shoe size, whatever, you can put that in your token. It becomes something called claims when you put it in there. And then your API doesn't have to go and call other services to figure this out. So check out OAuth Tools. It's pretty useful when you want to learn more. Quickly, if I add another scope here, OpenID, run the same flow again, you can even open it in a frame. I was already logged in, so it actually single signed me on. I got the new code, redeem that. I got a 3rd token. So now I changed from an OAuth code flow to an OpenID code flow, and I got something called an ID token. And this one I could decode right away because it's something called a JSON web token. So it contains the data. It's a by value token. So I can see already here, yeah, subject Jacob. I see other things, though. I see when did the user authenticate. auth time here, I can see how the user authenticated, well, with a method called username and so on. This token is for the client. This is how we can share identity information to the client. So here I can put other things than the things I send to the API. So let's wrap up. So we have these types of tokens. We have an ID token, we have a refresh token, and we have an access token. So the ID token we give to the client, and it can decode and see, hey, Jacob, you just logged in. The access token, the client sends to the API when it wants something. And the refresh token, I didn't mention that. That one we can use to obtain new access tokens once it expires. This one I wasn't going to do. So finally, what we should talk about is just scopes and consent. I mentioned them. We have the read scope, we have the OpenID scope, and they give some sort of indication to what type of access do we have with this token. A scope can be thought of easily if you think of consent. Very often in OAuth, you want the user to be involved and say, okay, if this is a third-party application, Nordic API's application is going to access want to read access to your data, and we're going to share the user ID with you. During login, then, an OAuth server would normally then show a consent screen saying, do you want to approve this? Do you want to do this? And if we think it's appropriate, we say yes. You've probably seen this with Facebook and others, Google and Microsoft. They usually do this because there's a lot of third party involved. So they say, do you sure you want this application to post on your wall, etc., etc. So consent is pretty easy to test in OAuth tools as well. All you do is, if your server supports it, you can send something called a prompt parameter in and say, hey, prompt me with a consent. It's a good way to test, at least. You could also force this from the server. So if I would run this again, I'm logged in, but I would be prompted now and say, do you want tools here, this client, to access these things? Sure, I do. And then I'm back, and I can redeem that code and get the tokens. Okay, so we're pretty close on time here. We have time for a few questions. I have 2 questions that have come in. The first one is about the user. How do I keep the user logged in for a longer time? If I need to run this flow, I assume you mean all the time. It's pretty intrusive to have the user redirected away and back and so on. And that's a pretty simple answer. The refresh token that we got and didn't talk so much about is there for the application to be able to get new tokens over time. So the refresh token can be very, very long-lived. It's used, you send it to the OAuth server together with your client credentials, and you will get new access token back. A common lifetime could be years. So your application can remember you. So as long as you, if it's a web application, as long as you have a session with that website, it can have that refresh token in the backend and pick it up and refresh, and it can continue accessing your APIs without having to reinitiate the flow. An app would store that in secure storage on the phone and pick it up anytime it boots, refresh, it's got new tokens, and it can start doing the flows. The other question was, are there any other options for OAuth now or onward? Yeah, that's a good question. Actually, no. OAuth has been, since it was OAuth 2, I should say, was finalized 2013, its first specification. And it has been adopted quite widely and is growing also in as a specification. There's a lot of additions coming. OpenID is also growing. I think we're up to almost 50 specifications now surrounding OAuth and OpenID Connect. So there's nothing else on the horizon for these type of problems. Rather, these specifications are growing and getting more and more advanced, more and more involved, solving more use cases. So I think we're going to see OAuth becoming more used rather than something else in the coming years. All right, we're out of time. I wanted to wrap up and just show you the thank you slide. Thank you for listening. We're going to have another of these webinars in August the 28th. I hope you join in. You can sign up on our website shortly. Also, you can check out OAuth Tools at our OAuth.tools website and find more information about the flows on OAuth on Curity.io. There's a resources button there. And there you can click and find details about how these various flows work. So thank you for listening.